please start by simplifying each of these two expressions. They're going to bring you back to some old skills, but we're going to see how we can use them in applying to our limits here today as well. And as much as we really might want it to, so you can check yourself, the answer to the first one is not h squared. Because when we have to do this 2 plus h cubed, that does not mean 2 cubed plus h cubed. Remember, you can't just distribute an exponent like that. That 2 plus h cubed, that's telling you that you're going to have to do 2 plus h times 2 plus h times 2 plus h. We got to multiply it by itself 3 times in order to cube it. And you're going to have to go through all of that work and simplify that down in order to be able to simplify this expression. And so when multiplying these together, I first multiply just 2 of the 2 plus h's, multiply those together, and then once we've done that, then we're going to have to multiply everything in that first parenthesis by everything in the second parenthesis here. And so once it's all multiplied out, this is what you should be looking at. Now once you have that, simplify from there. Alright, and now we'll look to see how we can simplify that. And notice we have this 8 minus 8. So those go away. Now notice what's left. Notice there is an h in every term in the top and in the bottom. So I can also reduce down the h's. And so 12h divided by h leaves me with 12. 6h squared divided by h leaves me with 6h. And h cubed divided by h leaves me with h squared. And so that whole big fraction reduced down to be 12 plus 6h plus h squared. And that is your final answer. And then once you've done that, you go on to the second problem. On the second one, think factoring. And yes, you can factor both the top and the bottom of that fraction. All right, now on to the second problem. Let's see how that one ends up working out. We got to factor both top and bottom. The x to the fourth minus 1, that is an example of a difference of squares. I can turn that, or I'm sorry, t to the fourth minus 1. That's going to become t squared plus 1 times t squared minus 1. Difference of squares rule there. On the bottom, we have a difference of cubes. So now you got to remember the difference of cubes rule, and how do we factor those? That's going to end up giving me t minus 1 times t squared plus t plus 1. And now I look at those results and I see what else can I do? Well, there's no canceling I can do right now. But there actually is a little bit more factoring I can do right now. Because you'll notice here, this t squared minus 1 on the top, that one actually could factor down a little bit more. So I'm going to go ahead and do that now. So the t squared plus 1 stayed the same. Because that's addition, I can't factor it anymore. But t squared minus 1, that can become t plus 1 times t minus 1. On the bottom, the t minus 1. And then the t squared plus t plus 1, does that factor at all? No, afraid not. So that's plus t plus 1. All right. So it looks like now everything's factored as far as it can possibly go. Is there anything that can cancel?
Yes.
Yes, there is. Notice the t minus 1's cancel out. And so my final reduced or simplified expression is going to be t squared plus 1 times t plus 1 on the top. And on the bottom, it's going to be that t squared plus t plus 1. Now the reason I had us do those simplifying problems first is because I knew I wanted us to be able to deal with these limits. And if dealing with it with the limit still in there, we might think that we're having to do all this stuff just because the limit somehow is telling us to do it, but it's not. The simplifying part is simplifying like you've always simplified before. It's using all rules that you've known from previous courses. So, if I'm going to then do these limits, first of all notice that I cannot just use direct substitution. If I tried plugging 0 in for h here, I'd be dividing by 0. On the other one, if I tried plugging 1 in for t here, I'd be dividing by 0. So that's why I have to change the form of each of these expressions in order to find those limits. And so, let's go ahead and change those forms. That means simplifying them. Well, we already did that, right? So for this first one, the limit as h approaches 0 is no longer going to be of that original one, but rather 12 plus 6h plus h squared. Now can we figure out what the limit is as h approaches 0? I think we can. Please do so. So once we've used substitution or whatever it is, then we just figure out what the whole thing equals. So then, that is telling me the limit when I do that direct substitution. I now do the math and simplify. The whole thing just equals 12. Wow. Now that's certainly a lot easier to work with, right? And it just meant that you had to be able to bring back those old rules from like pre-calc and algebra 2 and those classes in order to do the cubing or, in the case of the second one, the factoring. Because when finding the second limit, again, the first thing you'd have to do here is change the look of that expression. We need to try and find some way to make it so that it doesn't divide by 0. And in this case, that's by simplifying, factoring as we did. And that ended up changing it into the limit as t approached 1 of t squared plus 1 times t plus 1 all over t squared plus t plus 1. That's just the simplified version that we found in the last problem. Now, if I now plug 1 in for t here, am I going to get 0 in the denominator? No. So I can now use that direct substitution. Please do so. Plug that 1 in, figure out what our limit actually equals now. Alright, and so when we actually do that work now, on the top we end up doing 2 times 2. On the bottom we end up doing 1 plus 1 plus 1, so that is 3. So the whole thing ends up equaling 4/3. And there's our final answer. Over the last few days we've seen a number of different ways to find limits algebraically. Today we're going to be discussing the last of those that we're going to be doing for the time being, which is to combine the fractions. So add this to your notes. You now should have all 4 rules written down into your notes. If you're missing any of them, fill it in now. And then we're going to see how we can use that we'll actually find the limit. And so now we can see that we're going to be combining fractions. Now I'm going to be practicing this here in just a moment, but before I do, something I want to point out here. Really the only new thing when it comes directly to limits that we're having to learn here is this direct substitution idea. All of these other things over here were just variations on how to change the way the original problem looked so that we could hopefully make it so we don't divide by 0. All of them are just different methods of manipulating an expression. And so that's what we are doing even with those last couple problems, those last 2 limits we did. They were just examples of ways that we can manipulate them. Technically, if we wanted to put it under a particular category, they'd be like the factor and cancel kind of category. But it doesn't necessarily matter which category. These are just tools to use that let us manipulate the original problem and turn it into something that we can then use direct substitution with. All right, so now let's actually do it for this particular problem here where we can combine the fractions. So if I'm going to combine these fractions, that means doing the subtraction. And if I'm going to subtract fractions, I need to get a common denominator, absolutely. And so that's the first job here, is getting a common denominator. So it's still going to be the limit as t approaches 0. Now, to get a common denominator here, notice that that second fraction, I'm making my life easier by finding this first. That second fraction factors to 1 over t times t plus 1. The reason I like doing that is it tells me that I already have a t in both denominators. Nice. I only need to be putting the t plus 1 into that first one. All right, so I'm going to multiply the first fraction, top and bottom, by t plus 1. That will give me t plus 1 on the top of it. The bottom will be t times t plus 1. Go ahead and leave it in its factored form. It's actually going to work to our favor here shortly. And now that I've got my common denominator, I can do the subtraction. So on the top, I have t plus 1 minus 1. Well, the plus 1 minus 1, those are going to cancel each other out, so we're just left with t on the top. And on the bottom, we have t times t plus 1. Still. Notice what cancels. Those t's cancel out. And when I cancel out those t's, what am I left with on the top? 1. Absolutely. So it ends up giving me 1 over t plus 1. Notice now, where if I had tried to put this 0 into the original t, I would have been divided by 0. Now, if I plug that in, it's going to work. So I end up doing 1 over 0 plus 1, which is 1 over 1, which just equals 1.